Good morning, everyone. Welcome to this SDM webinar focused on the continuing airworthiness management organization. We will be presenting you some guidance to comply with the EASA occurrence reporting requirements. My name is Thierry Veron. I will be co-hosting this webinar. I will be presenting you mainly the first part of this webinar, the regulatory basis for reporting, the why to report, the what for, what is reportable and to whom. And I will be co-hosting with my colleague, Nicola. Good morning, Nicola.
Good morning. I'm Nicola Balzano, and I will be presenting the part on good reporting practice and guideline for CAMO. We'll give you some information about the importance of the aviation taxonomy and its key role for data management. And then we also see some good practice for high quality report. And then we'll conclude. So you will still have the possibility to send us the question. You will have until the end of February to provide your question. You can send them us to our functional mailbox report@easa.europa.eu. And then after this deadline of the end of February, we will take around 2 weeks time to put together our response, and then we will publish our response on our internet, and also all the material the presentation will be available on our internet website. Thank you, Thierry. The floor is yours.
Thank you, Nicola. So let's go for the first part. So we expect that this webinar will help you and guide CAMO holders to better comply with the applicable mandatory reporting requirements, fine-tune your policies and procedure, improve your screening of internally reported events, and also assess and address the contributor to safety deficiency detected at the CAMO organization as a system. So the very foundation of the reporting is here in the forms of the three forms of risk management. So the very first part, so for any system, we know that between the plan operation and the actual one, there is a difference between the plan operation and the actual performance. And that difference is what we call a practical drift. That drift leads to generally an unintended event, whatever the event may be. The worst one being an accident, but it can be a serious incident, an incident, or just an event, something that is not initially planned. And all the IDs. So at the beginning, the one of the form to manage the risk is the reactive one. Reactive form where you prevent reoccurrence or mitigate the severity of safety events. So the second part is the proactive way to manage the risk. The proactive way is a way to identify hazards mechanism and threats beforehand, and then you establish control measure to prevent initial occurrence from happening. So it's well before the timeline and the existence of the development of an unintended event. And then you have the third one. The third one is the predictive manner. The predictive is for you to attempt to anticipate future exposure based on past performance, data, and knowledge. These three forms of risk management coexist. It's not one against the other. They coexist, the three of them, and we use them at all levels. The level could be global level, could be at the European Union level, at the state level, or even at the organization level. You should be using the three forms of risk management. Another way to see this, to interpret the graph, is that the blue part is the compliance-based safety, while the amber arrow is the performance-based safety. So there is some historical shift where the first historical form of risk management was the reactive one, and then the predictive one is probably the most recent one. What you have to know is that it's a shift in the philosophy of risk management initially. So the reactive one, we were focused on high consequences, at least high severity, but low frequency event. While when you're on the other end, at the green here, at the predictive level, it's something that we are managing the events which are more frequent, so high frequency, but of lowest or low severity events. It's a different approach in the philosophy, but all of them are coexist, and we are using them. We use them at all level and in coexistence. So let's have a look now on the regulatory framework for CAMO. What is of importance for you is the green one, and we'll go into detail. What is not represented on that slide is the top of what they call the top of the pyramid. That would be the ICAO standard and recommended practices that most of you know through the name of ICAO annexes, Annex 6, Annex 8, Annex 19, Annex 13, right? So, and all these SARPs, ICAO SARPs, are reflected into our own regulation. So the basic, yes, indeed, the core regulation of interest for you is this one, 2018-1139, the EASA basic regulation, which in turns called a number of implementing regulation. They are not all represented here. One is missing is the part IS, for example, but the one for your interest today about occurrence reporting is mainly the 13/21/2014 for Continued Airworthiness Management Organization. You also have, called by this implementing regulation, the AMC 20-8, the latest version of the AMC 20-8 being the 8A for the time being. There is another part, a very important part of regulation for occurrence reporting, and this is the 376/2014 on occurrence reporting. Similarly to the previous one, that regulation calls an implementing regulation, the 2015-1018, which in turns call some annexes depending on your level, not your level, but your domain of operation. Typically, for you, is the Annex 1, Paragraph 2, dealing with technical occurrences related to the operation of the aircraft, and also some part of the Annex 2, Paragraph 3. This slide, just an example to depict what I told you before when it comes about the ICAO annexes. Here, a quick example of the Annex 8 dealing with the airworthiness of aircraft to show the responsibility of an operator, for example. The operator has to report to the type design organization, and in return, it is the responsibility of the type design organization to analyze the report that an operator or a CAMO or any organization have forwarded, as well as the state of design and the state of registry having also responsibility to verify the results of the analysis, whether when it comes about product safety, airworthiness of aircraft, the role of the type design organization is fulfilled and discharged properly. So let's have a quick example. It's just an example, but to show how the reports flow between organizations. One key center element in Europe, in the European Union, is what we call the ECR, standing for European Central Repository. Then we have a few actors, and actors number one will be EASA as competent authority number one. We will introduce a second competent authority, an EU member state, that will be dealing with at least with this this European member state will be the authority, the competent authority in charge of an EU Part 145 maintenance organization. We will also have, in our example, an EASA 21J design approval order. design approval order being, could be an aircraft type certificate order, an engine type certificate order, or an STC order. You choose. We will have also an EASA CAMO. What does stand in EASA CAMO? CAMO, EASA means in today's presentation on the other side of EASA. And we will also have another actor, obviously, the EASA AOC. So let's take an example. If the EASA CAMO has a reportable occurrence, if this occurrence is, let's say, strictly limited to the SMS of the CAMO, so it might simply report to its competent authority, i.e. EASA. Now, if this occurrence is not only about the SMS, or at least in the frame of its own organization, in a technical one, for example, it will have different linked or report flows to send to various parties, as we call. So it will be obliged to report to the EASA AOC, also to the design approval order, and to the Part 145 maintenance organization. If it's a technical, for which there is an action expected from the 145, or if the 145 is involved in the reported problems. In turn, those organizations will also have to report, especially if the occurrence is on the list of reportable occurrences for each of the mentioned organizations. So in the AOCs, if it's a reportable occurrence, they will also have an obligation for them to report to their competent authority, here EASA. If it's for the 145, if it's a reportable occurrences, they will have also an obligation, or that 145 will have an obligation to report to its competent authority. The AOC also will have an obligation to report to the design approval order. The same for the EU Part 145 maintenance organization. In turn, afterwards, the design approval order has an obligation, especially if what is being reported is identified as unsafe condition or potentially unsafe condition. So it's sent a report to EASA as competent authority. Then other obligations are on the competent authority of the European Union member state. Here, EASA has an obligation within 30 days to provide all occurrences and store all occurrences into the ECR, and similarly, the same for every and any European Union member state. Should member state also realize that there is either, for example, an issue with an organization under the other side of EASA, or the contrary, or the reciprocal, if EASA is aware that there is an issue with an organization under the other side of the European Union member states, then there are communication linked between the two. It's an obligation, and the agency or the member state, they have an obligation to exchange safety-related information. In the term that we use in the regulation uses safety significant information. So let's now enter into the various kinds of occurrence that must be reported to EASA. I use some color coding here to make sure you understand the distinction. There are literally not more than two kinds of occurrences that must be reported to EASA. The first one, appearing here in green, is the operator-centric SMS-determined reportable occurrences that must be reported to EASA as competent authority. Those are related to the safety of the organization operation. You find the regulatory references just there listed on the slide. The second kind of occurrences is the blue one, is the regulatory list determined reportable occurrences. The one that you find in the especially in the Implementing Rule 2015 annexes and the AMC 20. Well, those are related to the safety of the product for some, and some others to the safety of aircraft operation. And we will go now into detail on how to report to EASA these two kinds of occurrences. Let's start with the first one. First one, green color, SMS determined. So the SMS determined reportable occurrences are related to the safety of the organization. Some, and I say some, risk classification permitting, the way you classified and the risk you classified, can be reported to as closed on issue. It can be, but it's conditional to a combined EASA-approved procedure and risk classification. It can be, for example, from low risk up to marginally outside the acceptable level of safety performance. Acceptable level of safety performance is something you should be knowing. It's determined through application of SPI, safety performance indicator, and safety performance targets, and alert threshold within your safety performance management framework. So this is typically to be agreed with your CAMO team leader. Okay, this is inside your SMS organization. So you the regulation is to the discretion of how it's implemented by the CAMO team leader. Some, the asterisks, and the asterisks that it could also be most of the report could be reported as closed on issue for organization with higher maturity level. What does it mean? If indeed you have a high maturity, you are very experienced, your system, your SMS is working fine, and you have the trust from over the years from EASA, from your maintenance organization. Obviously, the level of where you can report open or closed will vary. If it's reported as closed on issue, it implies one and only one report, because there is no need for follow-up reports. No corrective actions are deemed necessary at CAMO level. That's the principle. Some, obviously, shall be reported as open. Open because the level of risk of the risk classification triggered a further need for investigation. One of the cases, obviously, is when you are outside of your acceptable level of safety performance. Now, if your report is open, an open report implies existence of a safety deficiency. At this time, it can be potential or actual. But for sure, open report implies likely need for mitigation and corrective action at the CAMO level. That's important to understand that. An open report implies one or more follow-up reports until submittal of a final report to be reported to EASA as closed. This final report shall contain your final risk assessment. It will document your mitigation or corrective action in order to your team leader, the CAMO team leader in charge of your CAMO, to review, comment, and accept your final conclusion contained in your report. A very important point as well, the last bullet here, is that you have to report to all necessary parties, as shown in one of the flowcharts that you saw previously. So design approval order, AOC, EASA. And please, when you report to EASA, indicate all parties that have been informed at time of reporting. It's important for all actors that you've seen on the flowcharts to know who is aware and where the responsibility stands for. The second kind of occurrences, the blue one, in today's presentation, are the least determined reportable occurrences related to the safety of the product or safety of aircraft operation. So this report can initially be reported to as closed on issue, especially when the CAMO is not responsible for the continued airworthiness of the product type design. It can be also, some can be reported to as closed on issue when the reporting CAMO is not the originator of the operation or maintenance induced event. You have to report it because it's on the list. You report it, but the originator might be, for example, a 145 organization that you work with. So you report to your CAMO team leader, you make sure that you identify what is the originator of the maintenance use event, for example, and in turn, this maintenance organization, if it's the originator, will have to, in the system, to open the report to its competent authority in an open report manner to process and analyze the issue that led to the occurrence that you have reported as a CAMO. Close on issue implies the same as before. If it's close on issue, it implies one and only one report, because there is no need for follow-up reports, no corrective action, mitigating action at CAMO level, especially if the originator is a 145, for instance. Not blaming the 145 here. Be careful when we use the terms corrective action. We are not talking about remedial maintenance action. It's different. Okay, the remedial maintenance action is restoration of continuing airworthiness. Here we refer to the part MA 301. Corrective action here inside your organization and inside the SMS framework. Once again, when you report this kind of occurrence, make sure that you indicate to us all parties informed at time of reporting. It's important so we can have the full visibility on who is informed, and especially allows us to communicate internally between section, or also with, if in the case of a new part 145 organization, to be able to discuss with the EU member state, the competent authority. So obviously, you must have, as a CAMO, you must have an internal safety reporting scheme. This internal scheme should extend way beyond the scope of occurrences required to be reported to the competent authority. You're expected also to collect and evaluate occurrences that are required to be reported. Please go to the CAMO A160 occurrence reporting, and particularly the guidance material 1 to CAMO A160. That lists all the documents where you can find a list of occurrences. We go here, obviously, the process the whole process is there for you to identify the cause and the contributing factor to the unintended events and address them as part of your safety risk management process. Recommendation here, the last bullet, have a look at the EASA part CAMO approval. It's a user guide for CAMO AOC. The latest version is dated November 2024. There is a new revised version coming soon. I cannot tell you the date, but it's coming in the next months, I would say. Have a look at the latest version is always the recommendation. Let's go quick in a way to see in the flow chart, the reporting process in a flow chart in a condensed version, because it looks like this. So let's see on the first, we start at the top left-hand corner. There is one of your staff experiences a safety event. So he will be filling a report, and he has from T0, time of discovery of the event, he will report internally. He has, per the regulation, up to T0 plus 72 hours to report to the organization. So we move to the second box, and here is the responsibility of the organization to collect, screen the data, the risk score, the event. Then you move to the first diamond on top, and here you have to ask yourself, is this event reportable per regulatory reporting requirement? Remember, as we've seen before, you have the list or the SMS one. The list, the blue one, the SMS, the green, as mentioned in the previous slide. If you conclude that it's not reportable, the event will feed the organization database, your database, for analysis and continuous improvement. If it happens to be reportable to your competent authority, here to EASA, ask yourself, where are you? Is there existence of a safety deficiency at CAMO level? Where are you compared to the level of safety performance? So if you identify that the cause, we are at this diamond, centered diamond. If let's have a look on the amber part on the right side of the slide. If the cause is intrinsic or cause of causes, and you have a high risk, you identify that you are in a high risk safety deficiency at CAMO level. So here, as a matter of priority, you have to send ASAP, as soon as possible, a report as open to EASA. And your report will contain all common and relevant specific mandatory data fields, your initial risk classification, a narrative expliciting the safety deficiency, but also possibly the preventive, mitigating, and or corrective action as found necessary, based, of course, on the element known at this stage. Because as you can see, in this ellipse timeline, it has to be done in 72 hours. So first is T0 plus 72, and then you have an additional 72 hours to do what is below the central diamond. So it's initial, obviously, but it has to be done within this time frame. The second option or second scenario would be the yellow one. The cause or causes are intrinsic, but instead of being a high risk safety deficiency, it's a medium risk at CAMO level. So here we expect you, it's not a priority, but you have a mid priority, and then we ask you to send expeditiously the report as open as well, with all the elements, common and relevant specific mandatory data field coming from the regulation 376. We expect to see an initial risk classification, the narrative explaining the safety deficiency, and also possibility of preventing, mitigating, and or corrective action at time of reporting. The last scenario would be on the green part, the left part from the center diamond, where the cause might be, we could be in a scenario where the causes are extrinsic, so not coming from your organization, the CAMO, or the option would be that there is no safety deficiency or a low risk safety deficiency based on your risk assessment and methodology you use. In that case, you can send the report as closed on issue to the competent authority, EASA in that case, that contains all common relevant specific mandatory data field from the 376 regulation, always the initial risk classification, the narrative, and conclusion documenting why your report can be submitted as closed on issue. It's important, you have to express that. We'll see further detail on it. What happens when you have submitted report as open to EASA, be they from the high risk safety deficiency or the medium risk sufficiency, the yellow and amber part? Well, in that case, you enter into a process for providing follow-ups reports. So it's the same text, but you are expected, the regulation says you're expected to provide a follow-up report within 30 days from T1. Okay, so you have to provide us with a follow-up report containing this time your preliminary safety analysis, possibly a revised classification, and therefore after that analysis elements that support you preventing, mitigating, and or corrective action found necessary and their respective timelines. Because depending on the action, you might need some time to implement to correct the contributing factor or the originator of the safety deficiency. And so it goes up to the very end, up to 90 days. That's what the regulation says as a guidance. It is expected that within T1 plus 90 days, you provide the final and closure report containing your final safety analysis, final risk classification if it has changed, and all the measures you decided to implement and monitor effectiveness of the action needed to tackle the reported safety deficiency. So 30 days, 90 days at most as a guidance. It can be, it can go extend, but normally for most of them, it can be and addressed within these T1 plus 90 days time frame. There is, however, one case where what has been presented does not work and deserve a different process. indeed, and this is in case where you have a high severity event, you might have, and this is part of the regulation, you might have to contact EASA immediately. So at that stage, literally, you might have a process that says in case of high severity event, you contact immediately your CAMO team leader, EASA. So pick up your phone, you send an email, but you make sure you have a two-way communication with your focal point at EASA, and you explain the problem. Only from that moment, you can re-enter in the system and provide further elements within the 72 hours. But it is important for high severity event that you can inform your CAMO focal points ASAP. Let's go further now on what is reportable. Summarize a bit what we've seen before. So the scope of your internal reporting extend way beyond the scope of occurrences required to be reported to the competent authority, and only a fraction is to be reported to EASA as competent authority. You have understood that there is the operator-centric SMS determined and also the regulatory list determined reportable occurrences. And I say there, have a look, read twice, because the regulation 2015 in terms of, and the annexes, there are plenty of subtleties on the occurrences to be reported. Remember that when you report as closed on issue, you have to indicate the reason why. For example, say it's a monitored safety issue. You say because it's monitored with the reference XYZ, and it's still within the acceptable safety indicators, safety targets. That's a valid reason, but you indicate why. And when it's reported as open, indicate also the reason why. The mitigation in place and type of preliminary analysis until submittal of the closure report, and your final analysis documented the corrections that you have decided to implement inside your CAMO, and with for each action the timelines of those actions. A few more. There are also some tricky AMC asking you to also report. So for CAMOs, there is the AMC 2020B on continuing structural integrity program. You have the reference paragraph 325 is on reporting system, and also the for those CAMO in charge of ETOPS operation, have a look at the appendix A to MC 20-6B, where you have some other continuing airworthiness consideration on occurrence reporting. Now we're going to move to the second part of this webinar about good reporting practices and guidelines for CAMO, and Nicolas will be presenting this part.
Thank you, Thierry. So I'll take over the sharing. Yeah, good morning, everyone. Yeah, so as I said before, I will cover this part on good reporting practice and guidelines for CAMO. So just a reminder to submit your question. Here you have the information, report@easa.europa.eu, and remember to submit the question no later than the end of February. And then, as I said before, we'll take around 2 weeks to prepare the response, and we will advertise on our website. So let's start. The main aim of my presentation is to improve the quality on the reports submitted by CAMO organization. That is the main aim of this presentation. But I have structured my presentation a bit differently. So we'll start talking about the importance of the CARES Aviation taxonomy and its role a key role for data management. So we'll go through what's a taxonomy, why it's important, what we want to achieve. And then we also see why it's important to keep the taxonomy up to date. And we repeat this concept of quality control. I know that each one of you knows already what is quality control. It is better to have a definition written down so you have it there for future reference. And then we'll have a look at occurrence category and event type classification. These are two mandatory attributes when you submit an occurrence report. We'll go over on how to, which value select, and we'll also provide some example there for the event types taxonomy, how we expect this to be used. For the occurrence category, there is a subset of all the category, because I had a quick screening through of all your report, and I've selected only the most relevant for you. For some specific case, you can use also the other. So the reference document is still the material produced from the CICTT, but you will we will go in detail to the most used one for the normal report you submit. And then we'll conclude with giving some practical aspect. So I call this from compliance to excellence. So it's like we already can already anticipate that the saying that we are quite happy on the quality of report we receive for you, but we will share some observation because we identified some area from improvement. So we'll share this with you. Thank you. So let's start. Yeah. So what's the first thing is foundation of aviation intelligence. What I call it like that. So just want to say something about here. Here at the agency, we do not collect occurrence report. We try to build a collective memory of all things that happen to us, and we want that this piece of intelligence, everything that involve our experience, is to be useful. It needs a structure, and the structure is given from the taxonomy. The taxonomy is our tool to use our knowledge given from past experience. So the taxonomy, as you see here, the first bullet point says that is a language. You can see it as a universal alphabet, that it doesn't matter to whom happened the event. When things are reported, this is immediately clear to an analyst that is in another country that is using the same taxonomy. Will immediately understand what happened to another person in another part of the planet. The importance of the taxonomy is it has a structured hierarchy. So it has this parent-child organization, so that we know where we are storing the information, and we can logically dive through or navigate through the structure, so we know where to look for the data. The data also, so our data is categorized. So these enable the data quality part. So there are specific values on what we want to look for, and then these enable the easy query logic, so we can find immediately the data that we have stored in our database. So we don't have to read all the 5,000, 100,000 of reports that are related to some specific things. The taxonomy gives us immediately the first filter and gives us the record that we are looking for. And it is an analytical tool. As I said, we want to extract knowledge from our past experience. But for this foundation to be solid and useful, we need to make sure that it is correctly applied, and we need to keep the taxonomy up to date. But we will see this a bit later. So why the taxonomy is important? The taxonomy is important. The first thing, it enables data sharing. It's a common. So if you are using the EASA taxonomy, you can share directly data with the agency, but also between organizations if they are using the same taxonomy. But here we are not forcing you to use the EASA taxonomy. You have to use a taxonomy. This is already powerful, but if we are using a taxonomy that is different, then of course there is the tedious work to mapping your values within your taxonomy with the EASA taxonomy, and sometimes this exercise can be difficult because the granularity is not the same. You don't have the exact values. And so the recommendation is still to use the Occurrence taxonomy, but it is the important is that enable quick and immediate data sharing. Then we have the other two bits here. They go together: trend analysis and identification of risk. So we want to spot patterns that could usually are invisible. So if you have some specific issue that happened to you, and you want to identify some specific maintenance issue that happen, human factor that usually comes up frequently, you want to see some trends, maybe the workload or other things that you want to address. And so we want go there in effective allocation of resources. So we know the problem that we want to solve, and there are some that are that we want to immediately resolve, and the other they have a different priority. So we can use the taxonomy to say us what we have to look for. And this is bring to at the end here is we want that our action and this decision are baked by the data and are not subjective. So if somebody is questioning our action, we can present an argument our decision, the decision that we have taken, showing the data behind. So what we want to achieve. So let's say with the taxonomy, we want to build our encyclopedia and everything that happened to us. So what happened to us, why it happened, and how we managed, what collective action we have implemented. Because we want to protect people and our asset. And we want to prevent reoccurrence. We want to avoid having the same event that hurted us. And so we want to avoid previous mistake. And we want also to measure our safety performance with similar organization. And if we are using a taxonomy that is the same used from the national authority or from the international agency, then it helps us to understand quickly the message given from the authority, and also understand better the publication. At the end, we want to close the safety loop. So something happened, we want to analyze, we want to understand what it happened, identifying our mistake, do a risk assessment, check the corrective action that we wish to implement. And at the end, what we really want, we want to communicate the lesson learned with our colleague on the front line, so that they know what to do in a certain situation and will avoid the reoccurrence and that event that can hurt us. And if you are doing all of these, this of course brings regulatory compliance. This is just automatic, because if you are having a taxonomy, you are having the taxonomy that we are using, you share the data with us, you are immediately compliant with the regulation. This is just a result of it. Why we must keep the taxonomy up to date? As you see, our sector is in continuous evolution. There are new technology released, drones, electrical engine. We have tons of data related to old innovation. Let's call old innovation, and we have there, we know what to expect. But for new innovation, we want to collect the information. We want to prevent accidents, something bad that happened to us. So we want that we want to promote innovation, but we want that innovation don't jeopardize safety. So we need to make sure that our taxonomy is up to date in capturing this data. And as well, we want to refine the definition and we want to reduce misunderstanding. So we want that people use the taxonomy in a standardized manner. And if we understand that some definition can be improved, we can do so by keeping our taxonomy up to date. What we want to do is to correct also our mistake. The taxonomy is like killing our domestic animal. Is not something that is written in stone. We want to remove duplicates. We want to correct mistakes, remove unused value. Maybe at some point in time we thought that was interesting to add some aspect in the taxonomy, but then we haven't used that. So we want to clean it from that, and we also want to fix errors or typos or something like that. We want also to fine-tune the granularity. So we have some aspect where we are too narrow, too specific, or in some other aspect we are too less specific. So here is where we fine-tune the granularity. And we also want a global alignment, is in the sense that all our organizations are using the latest taxonomy, and for this we have a requirement when reporting to the agency that you need to fulfill sending us the information according to the last version of the taxonomy. So yeah. I wanted to share a bit this definition of quality control. Not that I know that you have your own version, you know what it means, quality control, but sometimes I find it powerful to keep the memory and the knowledge vivid in my mind, to write something down and then look it again. So, and of course, having something written down is always good for future reference. And what is quality control is this enables our trust in the data that we have recorded in our database. How many of you as analysts have queried your database, and what you wish is just to search what you need, hit enter, and get the data out of the system? But how many times each one of you likes, when getting the results, start to doubt the result and then put the sleeves up and check the data one-to-one and see if all the data that were in the system are correctly coded and encoded, and then you can really trust what you got out from the system. Ideally, the analysts don't have to do that bit, because this is covered by quality control. So you just have to query the data and extract the knowledge out of it. So with quality control, we are verifying the compliance with the rules and definition of the taxonomy. I said before that with the updates of the taxonomy, we can refine rule and definition. Sometime here we can see that the taxonomy is applied not in the same way between different people. So here it can maybe an issue on the rule and definition that can be updated. This goes to the maintenance of the taxonomy, but we also want to identify gaps in the taxonomy. So if we see many times use the value other, unknown, or not applicable, maybe the granularity of our taxonomy is not the best, and we have to do some work there. Or something is missing, and we want to head that there. Yeah, the identification of rule and description I have already talked about, and yeah, what the last bit is what I call historical accuracy. We want to make sure that a value in the taxonomy means always the same. It's not that is written in stone, so something we can change our mind over time, but we need to make sure that if we change something, the data encoded in our database is updated according to and encoded according to the updated definition. So Yeah, let's go now to have an overview on the occurrence category. Here I give a bit a historical overview. In 1999, the CSTT was established. The CSTT is CAST ICAO Common Taxonomy Team, so Commercial Aviation Safety Team for the CAST. And they worked on not only on the occurrence category taxonomy, but also on other, for example, the aircraft make model, engine make model, or flight phase. But here we are talking about the occurrence category. The first release was in 2002. The first document that I could track down on the internet is dated 2004. So the purpose of occurrence category is to give a high-level classification on the occurrence, and is also introduce standardization and comparability. So we have standardized language, and so if I'm saying loci is we are online on the understanding of this category. I took loci only as an example. And multiple category can be assigned for a single occurrence. But for this specific presentation here, we are looking only at a subset of occurrence category. I have identified 4 that are commonly used for CAMO reported occurrence, and these are system component failure, non-power plant, power plant, other, and unknown. So we'll go through these four category, and then we'll see something else, the event type. So the first one is system component failure or malfunction. I think it was not power plant. Sorry, I clicked twice. Yeah. So this one is the malfunction or failure of a component other than power plant. So this includes error or failure in software and database system, and includes non-power plant part or pieces separated separating from the aircraft. And all 5 failure or malfunction including those related or caused by maintenance issue. So here I want to make a break, because in case the maintenance issue are not causing a direct failure, so for these specific things, these are not encoded into this category, because so the mistake have been identified before the failure. So in that specific case, we expect you code the category other. But in case the maintenance issue leads to a failure or malfunction of any non-power plant component, then you have to code it with this category. Then include also ground-based transmission, aircraft-based communication or data link system related to unmanned aircraft, and failure of ground-based launch and recovery system equipment. So in case there is also a note if failure make the aircraft uncontrollable, you should code only SFMP only. So in the case here, an example is in case let's say catastrophic event, in case the wing fall off, let's say break off, in that case the aircraft is uncontrollable, so should be coded only SCFMP and not as loci. Instead, if the failure leads to still to some controllable problem, but it doesn't, but leads to loci or loc G, you have to code both.
Loss of control.
Loss of control in flight and loss of control on ground, and those ones are not part of the today's overview. For next is system component failure or malfunction power plant. Of course, here we are looking at failure related to power plant. It includes failure to propeller system, engine gearbox, reverser, and the power plant controller. Any part of pieces separated from the power plant, And as SFMP, also failures and malfunction caused by maintenance. This goes the same observation I did before. If the maintenance failure does to malfunction of the part, then you code it as other. And also here the same observation on the notes. If the failure makes the aircraft uncontrollable, code SCFPP only. These one in this category are excluded fuel-related power plant problems like exhaustion, fuel starvation, mismanagement, contamination, wrong fuel, carburetor, or inductionizing. These are coded as fuel. And yeah, the rotorcraft main rotor and tail rotor system are coded as SCFMP. So in case in case none of the occurrence category, not only the SCFMP and PP are not fitting for the occurrence you are reporting, you can use this other category. But please don't use this other category in combination on any other occurrence category. And then we have unknown and undetermined. When you have insufficient information to classify and codify the occurrence category, you can use this value. Yeah. Let's jump to the event type taxonomy. The event type taxonomy was developed in 1976, so around 50 years ago, exactly 50 years ago. At that time, there were only 88 values. You see, with times, we have got a massive level of detail for this specific attribute, and we have over 3,000 values at the moment. And the main scope of this is to transform narrative text into a list of event type and have a standardized storytelling. So I know that when an initial something happened, we know only what happened, and then with time, with the follow-up, we start to know why and how we can restore things together, or how we dealt with the problem. But we want to code it into a standardized sequence. So we want to put why it happened to us, what happened, and how we managed it. And as you can see, as there are over 3,000 values, you can expect that the encoding of this information is knowledge dependent. So a senior analyst and a junior analyst will have a different knowledge of all the 3,000 values. So our scope here is to standardize the coding, but we are already in the artificial intelligence era, and we can use this new technology in the future, and we are already working today on it to support us in the usage of all the 3,000 value and make sure that we have a standardized way of usage of all the 3,000 values. So let's see at the structure of event type. Here you see the first. So the event type taxonomy has 4 levels. I can give you an informative how many. So for the level 1, we have only 7 values. Level 2, 84. Then level 3 is 451, and then the rest are for level 4. As you can expect, it's pretty difficult to condensate them into few slides. So here I've shown only the level 1, and so from this event, for this value you see there, only any other event and unknown don't have children values, while all the rest, consequential event, equipment, operational, organizational, personnel, they have children values. So there is level 2, level 3, and level 4. But let's see, I will focus here on maintenance-related events and human factor event. We will see in the next slide, that because it's the most that you will use together with the equipment. but the equipment I haven't introduced the overview. Those are broken down by ADA chapter, and for the main ADA chapter, these the taxonomy match with the design approval order ADA chapter taxonomy. So it's something that you know, and is broken down by ADA chapter, subchapter, and the specific component that may fail. And so for this presentation, we look at maintenance-related events. So aircraft maintenance is located under operational, and then you have this level 3. I have omitted the level 4 for simplification purposes, and you have this list of event accepted as storage of tool and component workshop events. So in case there is some problem with repair of a component, then you have fault isolation and troubleshooting. So if something has not been identified during the fault isolation, there is more specific code under that. Fault control during maintenance, installation, removal, repair, and test. This is where the most of the code we get. So incorrect installation by maintenance would be code there. Then we have maintenance, inspection, control, and servicing, sorry. And then maintenance planning and implementation. So service bulletin planning or worthiness directive planning, and maintenance use of tool and equipment if you had any the usage of any miscalibrated tool. Those are coded under this code, this value here. But here is just to show you a bit how it's structured. Then I invite you to navigate to the ECARES2 portal at the taxonomy, access the event type, and have a look at the level 4 that are there, so that you can provide this information to us. And you can also use, because this is also in your own, you can identify what maintenance issue you are facing. And then we have the human factor related event. These are located under personnel. As you see here, they are a bit more level 2 and level 3. So these are broken down by experience and knowledge events, personnel task performance, physiological events, and situational awareness and sensory events. And then you have knowledge and qualification, experience, and training personnel event for personnel and knowledge, and rest related to performance events. So you have action, communication, decision making, memory related events, non-conformance events, use of equipment, and etc. Then you have physiological events, so alertness and fatigue, impairment and incapacitation, and situational awareness, attention and vigilance event, and mental emotional state and perception event. So it's just to provide you an overview. Of course, we cannot go into details on the definition when you use one or the other, but some are pretty much straightforward to know, because you already provide in your text what went wrong. You have your identification of the human factor aspect. It's just to check and map what you have in your system with what we have it in the taxonomy. Yeah, and here I just giving you a practical example on how we apply the taxonomy. So you can see the sequence that I was speaking before, why it happened, what it happened, and how it was managed. So for this specific case, the flight crew experienced a cabin altitude warning at flight level 370. The flight crew donned oxygen mask and initiated emergency descent. During the descent, flight crew suffered change in air pressure. Mayday was declared. Flight crew uneventfully landed, and flight crew uninjured, aircraft with no damage. And you can see here what I was talking about before. about the breakdown of equipment. You have equipment, ADA chapter 21, air conditioning and pressurization system, subchapter pressurization control system event, and then we have cabin decompression. This happened on flight level 370, so during cruise. Then we have warning system triggered. We have this cabin altitude warning. There is not that level of granularity in taxonomy, so it's coded other warning system operation. And we have the release use of oxygen mask by the flight crew. This is under operational aircraft flight operation cabin safety, emergency descent and mayday call that are under consequential event and outcome event emergency situation. Yeah, so this is how we implement, and you see that from the sequence on the left that are in a chronological order on how they happened and how they occurred. Yeah, and then this leads to the final slide, at least for my part. So I called it from compliance to excellence. So it's like our observation on the data that we receive from you. So as I was anticipating, we are pretty happy on what we received. So the occurrence text provided, I mentioned the occurrence text, but here is like I'm intending everything: narrative, corrective action, risk assessment, conclusion, all those text fields. They are well structured and comprehensive. The accuracy and the completion rate for mandatory field are very high. But there is something that we want to share with you. Also some more sour notes, let's say. So you are already doing pretty well, but it's like usually complacency lower the standard. So we want to challenge you further. And so the part and serial number information are provided, but are not encoded into dedicated attribute. So here is some room of improvement. So then ensure accurate and complete encoding of the occurrence category and event type. This was exactly why we went into details on the category and how we are using event type. Here we see room of improvement. And then sometimes we have identified that some relevant documents are mentioned in the text but are not provided. I say sometimes is because this is not regularly, but we have identified some cases. And I want to leave with a powerful sentence that good data quality is always important because it shortens processing time, it clarifies what happens, turns information into actionable intelligence, and ensure that resources are focused where they are truly needed. Thank you. Yeah, so this is after the webinar, just repeating a bit what we already said. We will post the webinar on the EASA internet, and we will take 15 working days to reply to all the questions. And the video will be available also on our YouTube channel. And last reminder for the question, you submit them to our functional mailbox, report@easa.europa.eu, and you have time until the end of February. Thank you very much. Do you want to add something else?
No, thank you, Nicola, for your presentation. I hope to all of you the webinar was useful and helpful. You will find some references, additional document at the end of the presentation. Normally, we will be providing also the presentation support with the hyperlink, hopefully operational. And and for today, I think we can.
Thank you very much.
Thank you.
Thank you. Bye.
Thank you, and we close the webinar for today. Thank you very much. Thank you.